Hey guys, my name is Simon Fiedler and welcome again to another Houdini tutorial, and this time I show something different, of course. And this time I will show something that I presented in my Houdini learning progress reel that I uploaded like half a year ago, where I collected some scenes that are built in my first 4 years of using Houdini, where I practiced. And the thing I want to show today is something that a few people requested via email, and I thought it's a nice setup and maybe it's good to share that one. And I'm talking about this slicing tool that I built. It's not a new idea, so other people have also built it, but I just want to try it and it worked pretty well. By the way, the idea for that one came from my office colleague who is sitting right next to me. His name is Bastian. And we try to boil down the stuff that we need to calculate and to find out to build this was Bastian, that we need to build the setup. So if we take a look at the video here, you can see that you load in any kind of object and it gets sliced up into different slices. You can adjust the amount of the slices and the angle also, that it's not only horizontal slices but also in angles. And that setup was a lot of fun, and so I thought it might be worth to share it. So let's jump directly into Houdini and try that out. So first of all, we need something to slice, obviously, and for that I downloaded a free model from TurboScript. So let me just import that. By the way, we are right now on object level, so on scene level. If you're new to Houdini and maybe you're coming from Cinema 4D, for example, this is your object manager where you see all the objects in your scene. And first of all, before we import our geometry, we will create an empty container for our setup. And this is called geometry. So, and we call this one slicer. So double click it to dive into the slicer object. Double click. Here we are. And by default you find a file node here where you can import objects. You don't have to use that. If you want to create a sphere or something, you do that directly here. But if you want to import a mesh, we can do that here, and I want to do so. So click on this node and load your object, and the object I will load is a nice sculpt of Arnold Schwarzenegger, as you can see here, and we want to slice the Terminator. Alright, so how can we do this? First of all, we need a plane that cuts through our object. So, and for that, the easiest way is to simply create a grid. So the plane in Cinema is called grid in Houdini. So if we click that, we see it's quite big. As usual, my screen space here is very limited, so I'll try to make it as good as possible. And I'll activate the purple flag here, which is the template flag, so we can see both. So we see Arnold as a wireframe and our plane as the actual plane. And let's just resize that, maybe scale it to 3 by 3, just that we get an idea what's happening here. Okay. So what we want to get is this area here where the two objects intersect. And for this we can use a node called cookie. And the cookie is basically a Boolean object. So you have two inputs. You plug in object A and object B. And let's take a look at the result. And we have to set the cookie node from union to intersect. And then we get this here. So right now we get the area that we want and everything underneath, which is not what we want. So we have to split those two areas and delete the rest that we don't want. So easiest way is to click on groups and say create groups in the cookie. So by default you won't see any change, but if we activate the groups window, you can see we have different groups here, and one is called B in. So this is basically the inner area of object B. Object B is the second port, so our grid. So B in is actually what we want to keep, the rest should be deleted. So let's do that. Lay down a delete node. Connect that. And we want to delete primitives, and the group is called bin. And you can see now it's just the wrong way around, so we have to invert that. So operation, not delete selected, we want to delete the non-selected. So delete everything except of the group bin. And if I remove the template flag here, you can see we now get the slice that we want. And if I grab my plane here and move it, then you can see that we get the crosscut of our head here. Okay, step one is done. The interesting part, of course, for our slicers is that we don't have one slice, but a lot of slices. So let's do that. I will again activate the template flag here that I can see something, and maybe push our grid all the way down to the bottom of our object, somewhere here, maybe. That's fine, we'll fix that later. And then we use a copy node. As I mentioned in my video earlier, the copy node is something like the MoGraph cloner, so you can duplicate stuff, plug it in between, and let's say we want 10 copies, and translate in Y direction. If you go with your mouse over this field and click the middle mouse button, then you get the letter, and then you can simply move by left and right to move them apart from each other. Take out the copy sub now we have 10 grids going through our object. The cookie slices them, and you can see here that we get on this stage we have still some polygons on the side, and the delete sub deletes all the stuff which is not this area here in the middle. So on the next step, I want to remove all the points here inside of the slice. I only want points around it on the edge. So for that, we have a node called divide. Connect that. Click the display flag here, and in the divide sub, we have remove shared edges. And if you activate that, it will remove all the edges on the inside. So basically, every edge which is connected to which is connected on more than one side will be deleted, and only the ones on the outer rim will stay there. And next one would be good to we see some errors here, so we will see that we get rid of them later. I hope that's only a problem for now. Sometimes it helps if you just change the subdivision count on your planes, on the grid. That looks good for me. Okay, what I want to do now is to resample our edges. So right now if I activate points, we can see that all our points are not very regular, and it's a lot of them. So let's fix that with a resample. Lay down the resample node, connect it, and then you can simply adjust the length of each segment to your needs, maybe something like this. Don't make it too high. Alright. Now you can see that we have a very regular distance between our points. And but they are still not round, it's like straight lines between them. So we convert it. Convert. Connect that. So we convert our polygons to NURBS curves. So now it looks like a B-spline in Cinema 4D maybe, so it's very round. So let me deactivate that again, that you can see it. So here it's very edgy, and then I activate it and now it's round. Because now it's NURBS curves. Alright, sometimes it can happen. Let me see if I find an example for that. Looks like it worked pretty well. Sometimes you get on the end of your shape that you have like a spike coming out there, which is not really nice and round, which is basically the end of your curve, where it connects again with the begin of the curve, with the start of the curve. And if there's a spiky edge somewhere, sadly I can't find one right now. Seems like it worked directly. Is here one? No. So sometimes, for example, this rounding here is not perfectly round, so everything's round, but on this point, both of them come together, like this. And if you have that and you want to fix that, so we will build it in, because it can happen later if we change the count. Okay. Then there's one node called ends, the end sop, where you can actually define how the end of this curve should look like, or how it should connect to the start of the curve. And set clamp U and clamp V to unclamp, I think. That's right, to unclamp. Too bad that I don't have this problem right now here, but we'll see. Maybe I can show the example later again. Okay, so we have our end sop, and now that everything is nice and fixed, I want to convert it again, or to resample it again, to be polygons where I can specify exactly how many points I want on my slices. So we use a resample again. And now everything is round, but I can specify again the resolution of my slices. So maybe something like this. Now we have enough resolution to show everything. There's some weird stuff going on here, but again, it's possible if you can fix it by simply changing the count. Actually, it gets worse. So we will take a look at that later. Let me put that back. 50 maybe. That looks good. 50 looks fine. Alright, so basically we have a working setup already of the slicer itself. We have nice slices. One thing to visualize our slices better would be to color them in different colors. So let's try that. Connect the color node to this one, and then set the class to primitive and color type from constant to random. And then every primitive should be colored in a random color. If you have set that one to point, every point has a random color, which also looks interesting, but not what we want. So if you want to visualize, simply set it to primitive, and then you get every single slice in a different color. Okay, that's almost the basic setup. Last thing, what you want to do is to extrude everything. So lay down an extrude saw, connect that, and in depth scale you can adjust the scale of your slices to something like this maybe. And we're basically kind of done with that thing. So now we have Arnold Schwarzenegger in nice slices. Okay, the thing of course is that this is not the end of the setup, because we have to change everything by hand. So if you would load in another model here, the slices wouldn't fit anymore, maybe they are too small or too big or stuff like that, and that's not really good. So we want to change that everything works automatically, and that we can also rotate the slices in their orientation. So to do that, we have to find out how big our object is. This should be step one. So let's see, here we have our head again. And what I like to do is to lay down a null object here, which is simply a placeholder. But it's easier for us if we want to reference the object somewhere in our nodes here, and we can reference this one instead of this one, because that can change. And this is so every object that we plug in here will pass this node, and we can use that to reference it somewhere in our setup. And we call that input geo. And let's see how we can do that. So first step would be to use our, to take our grid. Let me ghost Arnold again, like that. So I want to place my grid directly at the bottom end of our object, somewhere here, and directly in the center of the head. And for that we can use the bounding box of our object that we load into slice. And to visualize the bounding box, there's a node called bound. So let's take a look at it. So this is basically our bounding box. So no matter what object you put in here, the bounding box will always be the box around this object. So let's see, like this, perfectly. And what I want to do, I want to read out the center of this bounding box, the perfect center, and the y position, the lowest position of this bounding box. And then write those values into the position of our grid here, so the center position, this one. So I will put it somewhere totally out of the way, that we can see if it snaps to the right position. And now we will use a small expression to tell the grid where it should be in space. So let me delete the bounds node again. And that was actually the first expression that I used in Houdini that worked. So maybe it's not too complicated and good to understand. So we want to read out the bounding box of our input geometry. And for that, it's always a good idea to press on this question mark over here, which is the help, the Houdini help. And let's type in bbox, which is the bounding box, and we click here on bbox expression function. And then you get this little help over here. So basically the expression is bbox, then you specify the bounding box of which object, and then the type, so what kind of data you want to read out. So there's x min, y min, z min, max, size, all the stuff that you can read out of the bounding box. And underneath there's something called related, the centroid. And before we do stuff with our bounding box, let's take a look at the centroid. So simply click here. And here you can see the centroid is the center of a bounding box of the points, not the average position of the points. So it doesn't matter if you have a spike coming out of here or a really big nose, then it won't take the center of all the points. It will still take the center of the bounding box of the object. So, and here we have our expression, centroid, then surface node, where you specify which object you want to read out the centroid from, and the type. So for example, the x, the y, or the z component of the centroid. And what I want to do now is take the centroid of the of our object and write the x position. No, x is in this direction. Write the x position of the centroid into the x position of our grid. So let's try that. So we click on the grid. And here, where we see the center, where we can adjust the position, this is x, y, z. So I'll type in centroid, bracket, and then you write dot dot slash, which means don't search in this node, but in that hierarchy here on geometry level, and it's called input geo. Like this. And if I click somewhere, our grid snaps directly to the x position of the centroid of our head. And I specify input geo in here. Oh, I forgot something. Because we need to, right, comma, dx. We want a dimension in x orientation, like this, right? Sorry, that was a mistake. So you can see that the x position now is correct. The z position is still wrong, so we will adjust that. So basically we can copy that one and go to the last field here and paste it in there and change x to capital C. And now it took the z position of the centroid of our head and placed the grid directly there. So we now corrected 2 of the 3 coordinates of our grid. So the last one which I want to take is the bottom of the bounding box of our object. So I can take the centroid, because if I take the centroid it will go somewhere here in the middle, but I want to have the plane somewhere, the grid somewhere here. And for that we will use the bounding box expression. So let's go back in the help file, what we've seen here. and we'll take the bounding box expression and we will use y min, which is the y coordinate, and there the minimum value, which is the bottom of our object. So let's go in here and type in bbox. Now // input, you can see it here, and then click on it, then you don't have to type so much, comma, and then the type is dy min, dy min, like that. And close the brackets, and that's it. And now you can see, then you can close the help file, now you can see that the grid snaps directly to the right position on the bottom of our head. We can also now use the size commands to adjust the size. Yeah, I think we'll do that also. We'll see if I can make it work without the help. So this should be bbox. So we want the x dimension of our bounding box of this head. So bbox of our input geo, and I think it's called let's see the help, x size, dx size, dx size, and we can see that it worked. So in x dimension our grid snapped exactly to the width of our head, and then simply copy it, paste it in here, and change from x size to z size, and we're done. Perfect. So if we now take a look at that, we see that our head is directly in the middle of our grids, and it's perfectly sliced. So if we take a look at the end of our setup again, deactivate the flag here, we can see that we have nice slices of our node here. But it's still not perfect because we see that a part of the head is missing up here. So what we also want to do is adjust, we don't want to adjust the spacing between our slices manually. We want to adjust the numbers of slices, but not the distance between them by hand. So basically, if we know the number of our slices and we know the size of our object, we can simply use the size of the object divided by the number of our slices, and then we know how far each slice has to be offsetted, that we can fill the whole object. So just for demonstration purposes, let's type in 10 up here, that we have 10 slices. And then again we will use the expression that we just used here, the bounding box, and go and translate, where we specify how far our slices should be apart from each other. And type in bbox, open brackets, input geo, comma, and d underscore y size. That should work. And this is divided by the number of our copies. Let's type in 10 for now. And that doesn't work. That doesn't work. Why not? Why not? Maybe we have to put that one in brackets also, the first part. Input geo. Oh, right, I forgot something here. So let me remove the brackets again, because I'm not sure if I need them. So of course we don't type in input geo, we type in // input geo. So now we'll find it. And we can see that it's now divided exactly by the number of slices that we want to have. So if I type in 20 up here, and also 20 in here, it should fit perfectly, which it does. So right now only the extrusion is too far, but we can see that it fits very nicely. So two things that we want to change here. Number one is I don't want to type in a number here and then also a number in here. We want to link those two together. So what you can always do is click here on number of copies, say copy parameter, and then paste it in here as a relative reference, which means it's something like a live link. So if I would paste it now in here, it would destroy my expression that I have in here. So just to see how the expression look like, I'll take some other field here and say paste copied relative reference, just to check out what I have to type in here. And we see it's just CH, which stands for channel, and NCY, which is the number of copies here. So I just copy that, right click and delete channel again. So you only have to do that if you don't know how to write this expression, and I forget that all the time. And in our Y offset parameter, I will delete the 20 and paste our expression. Channel, number of copies. And if I now change the number of copies up here, you can see that it distributes the 5 slices across our object. One thing which we can see here is, you see that the last slice is underneath the end of our object. I think Manuel always calls it the garden fence problem. So if you want to divide a distance with 5 slices, you basically have 4 spaces in between. So it's always one less. So we can adjust that also in our expression here. So we don't divide it by the number of copies, but by the numbers of copies minus 1. Close the bracket. And now you can see that the first grid is on the bottom of our object and the last one is on the top. And all of the other ones are in between. So if we now change it to 30, for example, it takes a while to calculate the cookie. And then you should be fine. So let me disable that again. And we can see that we almost have a nice working setup here. One thing we also want to change, of course, is the extrusion amount. So let's click on the extrude again. And this depth scale here, I don't want to adjust that by myself. So I also want to have the setup taking care of that. So let's also link this one to this one here. So basically, our slice should always be so thick that it fills the gap between the actual slice and the next slice. So we want to link the value which comes out here to the other one. So simply right click on this field, copy parameter, scroll down, go into the extrude again, and on depth scale, right click, and say paste copied relative reference. And now you can see that it's perfectly in line. It will fit very nicely in here. And if we go up again, change the number of copies to, let's say, 60. Wait a second. And now we have Arnold Schwarzenegger in slices with 60 slices, and all of them are very nicely connected to each other. Alright, so this is step 1. I just recognized that I say that all the time, this is step 1. So this is actually not step 1, but this is the first part, and now we have a working slicer setup. What was interesting for me was to extend this one, because I also wanted the slices to be in another angle, that I don't have like perfectly horizontal slices, but also angled ones, like for example diagonal through my object. So how can we build that one? The interesting thing about our setup is that we use the bounding box of our object. So no matter if we rotate our object, for example, the bounding box still is perfectly aligned. So we can leave everything how it is and simply rotate our head. So let's try that. We create a transform node, plug it in between. this. And if I now, for example, rotate the head in this direction, like so, and jump to the end again, let it calculate, then I get nice angle slices, which look super cool. The thing is, of course, we don't want our head to be like this. We want it in the normal rotation and not rotated somewhere in another direction. So what we want to do is take this transform node and put it also to the end of our chain and simply invert the rotation that we put in up here. So what we want to do is take another transform node, like that, put it in the end, display flag on that one, and now I click on the first transform node and right click on rotate, so it copies all three of those values. Copy parameter, go down to the last one, right click on rotate, paste copied relative references, and now of course it took the rotation and did the rotation again, so we doubled the rotation now. But if we see our expressions here and simply type a minus in front of the expression, it will rotate it in the other direction back. Like this. Okay, and now we have one little problem here. So if we take a look at our initial geometry, oh, now it worked, right. Of course, if I now rotate in another dimension also, maybe here, 20 degrees in that way, let it calculate, then you can see that our end result is not perfectly aligned anymore. And this has to do with the rotation order of the axis. So on the first transform, you can see that this is the rotation order. We rotate in X, Y, Z. And if we do it backwards, we just have to invert this order here. So click on the last transform and change it to ZYX. And now our sliced model again is aligned like the first one. So it fits perfectly together. Yeah, so this is our working setup here. So let me check. We have half an hour. Maybe we can extend that a little bit. Maybe set the number of copies to 30, that it calculates faster. And I think this is already a super funny setup where you can do a lot of very nice effects. I also tested it with animated geometry, which is also interesting because the slices are fixed in space and the object moves through the slices. But what we want to do now is also convert this one into a Houdini digital asset that we can use it in Houdini or maybe also with Houdini engine in other programs like Cinema 4D. So to do that we have to make some preparations here. And the first one is to build an input port for different kinds of geometry. So I will remove our Arnold over here. So maybe I will also save my scene file, maybe. Slicer. And instead of the mesh that I plugged in here, I simply use an object merge. So the object merge is a node where you can bring in geometry from other places somewhere in your Houdini file. So if you have a model somewhere up here in another network, you can bring it into this one here via this node. And we use that as a placeholder for our digital asset. And we call this one input geo. No, the other one is called input geo. Geometry import, maybe. And we make it green. Just let me know this is the input where everything comes together. Okay, so we jump one level back, just hit the U button on your keyboard or click here on object level. So this is our slicer setup packed into one node. And what we want to do is right click and say create digital asset. And we call this one slicer. And also store it somewhere, maybe here, slicer v1 or slicer asset maybe. Accept, hit accept. Then you get a warning, but simply click on no changes, and this window here pops up. And I also explained that in another video, but we will take a look at the parameters of this level here. So basically, if you click on the slicer node right now, you see some stuff here, like the transform attributes, the material, render attributes, and this is what you can see here. So this is the, in Cinema 4D, this would be the, how was it called, user data panel, where you can specify your own user data and own sliders and stuff. And what we want to do now is double click on the slicer and dive into our setup again, and now find all the attributes that we want to change, that we want to be able to change on our setup. So first thing we want to do is bring in a field where we can drop in our geometry that we want to slice. So for that, click on this object merge node up here, and this field here, object1, is basically the object which is imported into the setup. So simply grab the object1 and drag it over here and just store it here on the root object, and then you can see the, let me make this one bigger here. So here we have our object1, and let's call that object to slice, and the label also object to slice. Okay, apply, no changes. The next one should be maybe the amount of slices, so the count. So click on our copy node, and here number of copies, drag that one in, also on root, and call that only the, rename the label to number of slices. Try that. And what else do we need? Maybe here in the transform, the orientation of our slices. So simply take the rotate value, drag it onto our root object, and name it slice orientation. Alright, so that's it for now. What else can we do here? Maybe, yeah, this is also a good idea. Basically, that was something that Bastian said earlier, which would be nice. So right now, let me bring that one out of the way. Right now, our slices will always have the perfect thickness, that they touch each other perfectly. But maybe you want slices which only have like 50% of the height of the space between the slicers. So maybe we can bring in a value here or a slider where we can say, okay, only use 50% of the thickness. So we click on the extrude, and first of all we need to create a slider for that. So in the extrude object, click on this wheel up here and click on edit parameter interface, the first point in the menu. I think it's cut off by the screen recording, but you will get this window here, and in there on the left side, this is all kinds of buttons or fields that you can create on this object. And we want to have a float, which is simply a value between 0 and 1, for example. So drag that onto your root object, click it, and under parameter, you can give it a name. So we call this slice thickness. Also here, slice thickness. And we will limit it to a range from 0 to 1. And also simply hit apply and accept. And then you can see that on the extrude node we have a new slider which is called slice thickness, and of course it does nothing because it's connected to nothing. But what you can do here, let me check again how that works. Right. So this is basically where we typed in our expression earlier to take the distance between the slicers and simply use that value in the depth of our extrusion, in the thickness of our extrusion. So what we want to do is use that value and multiply it by our slider that we can say, okay, set it to 0.5, then it will only take 50% of the thickness, and it's only half the thickness, right? So I'll simply put that one in brackets, like that, and multiply it by the channel slice thickness. Here we are, like that. Alright, that should work. So now we bring back our window where we defined our all the parameters for our Houdini digital asset, and we will bring in the slider slice thickness in here also. Bring it on the root. Alright, and now we have the object to slice. Excuse me. Alright. We have an input field for the object to slice, the number of slices, slice orientation, and the slice thickness. And now we can pack them all together into a folder maybe. So on the left side, grab a folder, put it on root, and bring it above the renderable field here, and call it slicer parameters, maybe, and put all of our controls that we just made in there. Oh, what happened here? Sorry, there was a mistake. So bring back our slide thickness. Alright, create a folder. Put all the objects into the folder. Now it worked. And call this one slice parameters, or slicer parameters. Right? And bring it above this one here. And if you now hit apply and say no changes, and accept, no changes, and go back, and you click onto our slicer HDA, you should have all those objects down here. Actually, I want it up here in a tab. I thought it worked, so we have to adjust that. So again, click on this one, edit parameter interface, and I think you just have to change the order here. Somehow my folder disappeared again. Okay, let's try this. Right, click on all of them, put parameters in new folder. Okay, again, slicer parameters, slicer parameters, that. Put it in here, right? Here it is. Apply. And now it's up here. Now it's fine. Okay, close it. So we have our Houdini digital asset here. You can see it because the the text is red. And if you click on the asset, you have the tab up here, slicer parameters with all our values that we typed in here. So let me set that to 0 and the number of slices maybe to 10 and slice thickness to 1. And now we want to bring in an object in here. So let me import Arnold again. So we call this one Arnold. And import the OBJ again. Accept, go back. Make it invisible, and now if we click on our asset, we can specify. If we click on that button, we see the objects in our scene, and we simply take Arnold, accept, and then it loads up, and we see Arnold sliced. So of course we can now change the amount of slices in here without diving through our asset itself. So we have all the values up here, which makes it very easy to work with. So maybe like this, oh yeah, like that, or maybe also 50 degrees in that direction. So now you can play around with it and you get really, really nice results. So this is really, really cool. And Of course, we can now also use our slider here and say, okay, don't fill the gaps completely, fill them by half, and then you have gaps in between, and stuff like that. Alright, so that's basically it. I hope you enjoyed it, and I'll see you next time with another tutorial. Bye bye!